Version 1. Good observation. Anything related to the timestamps that's interesting? Every 5 minutes I heard someone say that. So what you see is the same IP address posts something to execute.asp with the same session ID every 5 minutes to the T, except for one of those cases, I guess, where there was some sort of a network delay. It led to a 1 second lag. What does this tell us about this attack? It's automated. It's probably an automated attack that's occurring. Someone's written a script to keep posting to execute.asp with a particular session ID.
I got a question.
Yes.
Well, this attack, so you're making a whole bunch of people buy software. Why? What just to prove that you can do it?
It's a pump and dump. They're trying to. They've bought stock before they started the attack at a low price. They make all these other people buy the stock, bring the price up, and then they sell it.
Yeah, that was a great question. Why were they buying stock using other people's accounts? Like Chuck said, they were artificially inflating the price of this penny stock and were ready to sell it. So the other 983 folks who didn't report it were going to have a good time. So what we saw was there was multiple requests for execute.asp occurring approximately every 5 minutes from the same IP address using HTTP version 1.0. So after we noticed that, we said, let's pass out all requests with that particular suspicious session ID. Well, you don't see the same session ID occurring every 5 minutes. There seemed to be something wrong with that. So there you see the log parser query saying, well, that particular session ID in the URI query, show me every single one of those requests from the web server logs. And here's what we found. Looks pretty similar to the previous one. But what do we see there? Change an IP address. Interesting. So we see another IP address now using that same session ID. What else do we see? I'm sorry? Login. We see requests to login.asp. It's not just execute.asp. After login, there's access to account.asp, execute.asp, and then confirm.asp, kind of what seemed to be a logical flow of executing a trade. So what was interesting here was it seemed like someone from this particular IP address, which is the 22.33, again, a fictitious IP address, kept pinging the application every 5 minutes in an automated fashion, trying to get in there. Something gave way when you see this particular .33 IP address actually get to the confirm.asp page, confirming for us that he was actually able to execute the trade. What gave way? I'm sorry? ID and password. Well, why didn't he use it at 1:03 in the morning if he knew the ID and password? The user was logged in. Who said the user was logged in? You deserve another personal invitation from me. You say that? The user was logged in. So what appears?
Okay.
So what appears to have happened there is someone coming from a different IP address logged into this application at approximately 2:07 in the afternoon. Following which, you see that the malicious IP address, the .33, was able to go on from execute.asp to confirm.asp. So the attacker almost seemed like he was waiting for someone to log in with this particular session ID. The moment that happened, he was in. How would you classify this attack? I hear session fixation resounding in this hall. That is right, it is session fixation. But what is interesting is, why did it take that long? What happened? How did this guy guess a valid session ID to the application? You look at that session ID there, it's damn 32 characters long with random numbers and digits and whatever else in there. I'm sorry? He waited for it to repeat. That was my initial thought as well. He probably waited for it to repeat, but that would have been kind of a longish attack given the character space that these session IDs actually go through before they repeat. What else could have been the reason? Predictable, stole it. It could have been any of those. He knew the algorithm, which would have been a smart attacker, but he wasn't that smart. I'm sorry? I wish you were on my team when we were responding to this incident because the dumb guys couldn't guess that for 48 hours. Oops, sorry.
Oh.
The answer was the application actually handed out the session ID before you logged in. So you hit the application said, okay, sir, here's your session ID. After you log in, we will repeat the same session ID and activate your session with it. Yes?
Is that because you already had a cookie from the previous login and it saw the cookie and then established the session ID?
That's correct. He didn't have it from a previous login. All he had it from was just hitting the application, unauthenticated, getting this particular cookie/session ID and saying, well, now I'm going to reuse this and try to have someone activate their session with this particular session ID.
Yeah, we're going to get to how the victim
Right.
got the session ID. I think that's what you're getting at.
Yeah, the big question was, how did he force someone to use this session ID? And we were still stumped at that point. Well, now comes in the team who was actually looking at the host of the victim, the end user machine of the person who we thought might have been compromised by a keystroke logger. We started looking at the machine. There was no evidence of key logging Trojans, no malware, viruses. It was a pristine machine. But what we found was an interesting archive.pst file. For those of you who don't know that, it's the archived inbox out of Microsoft Outlook. We found an interesting email in there. An interesting email was from customer service of this particular brokerage firm. At first, if any of us looked at it, it would not have appeared to be a phishing email. It did not have typos. The grammar was good. It did not appear to be a phishing email. But like all of us know pretty well, we don't click on these emails. So when we interviewed this end user, we asked him if he clicked on the email. He was actually offended when I asked him that question. And he was offended because he thought he was pretty techno-savvy and said, I know better than that, but in this case, I did click on it. And I said, well, if you know better than that, why the hell did you click on it?
Well, in the user's defense, I mean, that does look legitimate. It's going to the real brokerage. It's going over HTTPS.
Exactly, and that was the reason he gave me. If you look at the URL, I've expanded it down there. Well, the click here URL that we looked at was actually going to the brokeragefirm.com/login.asp. It wasn't a random IP address going somewhere to Eastern Europe or somewhere in the Pacific Ring. It was going to the brokerage firm. All it had was an appended session ID to it. And guess which session ID that was? The one the attacker had already got by hitting the application, and it gave it to him prior to login. So the pieces of the puzzle kind of came together. It was a combination of social engineering and poor application design that led to this attack. People were able to conduct session fixation attacks. So just as a summary, you guys already picked it. It was session fixation. Session ID was issued before login, and he was able to successfully social engineer a couple of people at least to click on that link, activate their session IDs, and thus get into the application, execute these false malicious trades. Any questions on this case? How did he get email addresses? Very interesting question. We did not have time to investigate that, but our suspicion was when we looked at the application, there was an interface on a particular page that accessed end user data, and that was susceptible to SQL injection. So we thought it was a SQL injection attack hitting a completely different database that had email addresses in it as well. Any other questions?
Where did you detect the source of the attack from? Was it overseas, US-based? Where did you determine it came from?
It was overseas, and we'll leave it at that.
So the application was built such that even though it was issuing you the session ID, it would accept the user input session ID. That just doesn't make any sense. That basically what it's telling me is I pass through a URL, and I tell you what session ID I want to use. The application will accept that.
And you will be surprised to know almost every application we assess, especially ones which use JSession IDs, are vulnerable to this attack.
Yeah, but part of the problem with this is that they were rolling their own session management. They weren't using the standard ASP.NET session stuff, and that was part of the problem that led to this.
Right. But if you look at a lot of the JSP-based applications, they are susceptible to this sort of an attack. Even though the JSession ID is an extremely random, strong session ID, they are susceptible to session fixation. Okay, so I'm going to pass it back to boring Chuck.
Yeah, I get all the boring slides, but like I said, we're going to go through these quickly because they're not near as much fun as Rohit's stuff. So we talked a lot in that case study about logs, so I just wanted to put some slides in here, like I said, mostly for your reference about where the logs are in a typical web application. IIS, at least 6.0, they're going to be in the underneath your log files directory, and they are easily parsed with your log parser, or you can even just open them up in text editor. That's fine. And we're going to talk a little bit more in detail about what they do what they do capture by default, which is basically what we were seeing in the slide earlier. They were just using basically the default logging. So you're going to know the date and time of accesses, your client IP, server info as far as the IP of the server, the host name of it, and then the method use, URL and parameters, status code, user agent. So that's useful. There's a couple other things you might want to add. You can actually log transfer sizes, which is useful if you're trying to see what kind of data people are pulling back, especially if you see a lot of times automated attacks are going to be looking at the sizes of the responses in order to detect if something was successful or not. And then you can log cookies and the referrer header as well. And unfortunately, you cannot log with IIS6 any of the post data. So the data that's inside the post, the body of a post request. Some would call that a feature because post data is supposed to be kind of sensitive and not logged by proxies and that in between the client and the server. But for the server, it's important, and we're going to talk more about that in a second as well.
Actually, before Chuck even moves on, why do you think the post data is important? And actually, I think that's the next slide. But
well, I just showed it to him. But.
Right. Let me. Yeah. Why do you think the post data is important? Yes. Exactly, great answer. The fact is that a lot of your SQL injection attacks, cross-site scripting attacks, etc., might target parameters that are passed via post to the application. You won't see any of those in your web server logs. And how often do we see applications actually logging violations to input validation? Who's seen that? Oh, my application logs a potential SQL injection attack. I've never come across that. So basically what you're saying is you lose all this important data by not even providing the option to log post parameters.
Yeah, if there's any Microsoft people here, then we're expecting that to be fixed in IIS 7. Take that as a task.
Why wouldn't it be a governance issue, though? So if you have a post, right, that it could contain PII or DHI, then it may not be able to be tracked in certain governance.
Well, it's one of those things you should give the server administrator the option. I mean, there are certainly, and it should probably be on a per page basis, especially like login pages. You may not want to log the post parameters because it's going to have the username and password that then you got to keep track of who has access to that. But in general, there's a lot more to be gained by it than to be lost by it. And a lot of it comes down to you secure your logs properly. You make sure that only the right people have access to the logs, then it's not as big of a deal. But yeah, there's certainly issues. It shouldn't be something that IIS just does on its own automatically. It's like, but you should be able to configure it. It'd be nice to at least have the option.
Yeah, and actually it helps in when you're really asked the question by executive management to perform a damage assessment. What was taken by the attacker? There is no right answer if I cannot see what was carried in the post data. All I can tell you is from the get parameters, yes, it was a SQL injection against some parameters passed via get, and potentially 13,000 credit card numbers were compromised from this table, but I have no idea what happened beyond that.
Yeah, that's what key there is that, yeah, being able to go back and figure out exactly what happened as far as that. So that's why we care about post data, and Rohit's going to talk a little bit about why we care about cookies.
So going back to another case study, in May of 2006, we were actually contracted by a multinational food and beverages company. They had put out a tender of sorts, a contract out there, and they had an online system to accept bids from different contractors. There was someone raised the suspicion that there might be a particular contractor who knew the bids of others and was able to cut them out of competition. We were brought in to kind of investigate that from a computer security standpoint. The chief counsel was all worried at that point. In this case, actually, they did have the cookies logged in IIS6, which really helped us solve the case. Had that not been the case, there was no way for us to do that. Because what we observed is we perused through the IIS6 logs and we found the same IP address. And when who is that? It was one of the contractors, was basically accessing the